So here's a few news articles. This one here I've heard a lot about, and this article has a bit more details. We've been sending up satellites for several decades, and a large number of them just float up there for many years, and it's getting very hard to send further rockets up without hitting the junk, and so this is a huge problem. So they're trying to plan things. One of the many problems is the light contamination it creates. You can't take telescopic pictures of the sky anymore without seeing all these satellites, especially Elon Musk's new project to put up satellites to give everyone cheap internet. It involves putting up thousands of satellites, so there's just clusters of them, and they streak across, and it turns out satellites are very bright. Now, Caitlin told me that today she saw the ISS. So the ISS, the space station, is apparently so bright it's very easy to spot. You just have to look up the right time to look because it goes pretty fast. But it's very bright, brighter than the stars. And a lot of satellites are very bright. So one thing they've begun doing is carefully making satellites out of darker material, but they've been not doing a good job of that, and they're still far too bright. And so that's one issue, is to make all future satellites much less shiny, so they will not contaminate the light space so much. And in order to deal with the physical damage caused by all these satellites and junk floating around, they're developing various systems of going and cleaning it up. And so there's things that will go up and grab a satellite, and they've been testing a gadget that will go up with a 2,300-yard long electrodynamic tether, which will knock passing debris back towards the planet till they burn up in the atmosphere. So this is sort of like there are little robotic boats floating around in the ocean now trying to clean up all the plastic in the ocean. So a similar activity, which I've heard people say younger generations should really focus on this if they want to have a growth career, is carbon fixation, things that will clean the carbon out of the air and put it in something like minerals that will get that will prevent global warming and reverse it. In all these cases, we polluted things to such a large extent that there's actually a major industry available to clean up the pollution. This is quite significant. I've been talking about this for years. Yeah, carbon sequestration. Yeah, that's the term. And so Google built Android, and they used Java code in Android. And then Oracle bought Sun, which was the owner of Java, and they sued, saying Google had exceeded fair use. You are allowed to use other people's code up to some extent of fair use. And it was a matter of $2 or $5 billion at risk here. Now they say it apparently should have been $9 billion when I wasn't paying attention. But this was also considered very significant for the future of technology, because what Google did was they copied a tiny bit of the code from Java, but they copied the code that defines the API. And the API is how your code interacts with other people's code. So it's how you make a structured request coming into something like Facebook saying, I want to let this person log in with Facebook, and or something like that. And so you have the API is pretty much what must be uniform in order for code to interoperate. So if you weren't allowed to copy somebody else's API, it would really sort of make it difficult for software products to work with each other. So this is regarded as a major victory for software developers all over the place, that cloning somebody else's API is not considered invasion of copyright. It's kind of necessary to do that. So that seems like a good sign, and that was the Supreme Court, so that, I think, should be the end of it. I don't believe you can appeal anywhere after that, so hopefully that'll be the end of it. The Florida governor, who looks to me like to be one of the major contenders for the next president, is now suing to run cruise ships. He's all along been pretty much ignoring COVID entirely, and now he says, well, people are going to sail anyway, so they might as well sail here so we can get the money. So we'll see what happens. This is like the issue of vaccine passports and other things. A lot of people are not taking the vaccine, and yet they want to just go back to normal life and spread it. The vaccine is, however, apparently very effective, so presumably those of us that have taken the vaccine can more or less ignore this. If these people choose to risk their lives, we'll see what happens. I saw an article today, or a comment saying that made me think a little bit, that said that, when they tested the vaccine for effectiveness, they tested it against a world that was in lockdown and wearing masks, supposedly. So it probably isn't as effective if you were to do something like go to a concert or cruise ship full of people not wearing masks. But on the other hand, a large number of those people are infected, so we just don't know. But the current information I've seen predominantly says that if you have the vaccine, your chance of getting reinfected is extremely small and you really don't have to worry. So I'm hoping that remains true. I was very interested to read this. I did not know it. There are a bunch of nuns worldwide, although not so much in America because the Catholic Church is not doing so well at recruiting nuns in America, but in India and other nations, these nuns go to places where pimps pick up runaway girls and get them into lives of prostitution and drug addiction, and they counsel them and give them cards and say, don't go with this man. They ask them what's going on. They say, this is a bad man. You're not going anywhere. And they're apparently very effective. And the pimps are pretty much criminals, and they've tried to stop these nuns, and they've learned that you can't stop them. Even if you beat them up, even if you threaten them, they're dedicated, and they will keep coming back till they've learned to just sort of tolerate them. So there's a worldwide sisterhood of nuns doing this. And it sounds like a wonderful thing to do. Reminds me of Thich Nhat Hanh, a Vietnamese Buddhist priest who went around providing medical service to all sides in the Vietnam War. And many of the monks were killed for being spies, and the same thing happened. They couldn't make them stop. And I think most sides eventually learned that they were not spies. They were just trying to offer medical treatment to everybody. Deviant Ollam is a great guy. He came and gave a talk to my class a while ago demonstrating how to pick locks, or how to not pick locks, really. He wrote a book on picking locks. He's a physical penetration tester, but he pretty much quit picking locks because he found out it's easier to get through doors by making little things with strings and dental floss and coat hangers to just reach around and pull the knob and so on. And he demonstrated this. It's all very effective. And now he is teaching a class in elements of disguise. And here he shows how you make a quick change disguise. So he got a suit, and he can immediately turn into like a Trump supporter with a red hat. And this is what you do. And so he went to the thrift store and bought used clothes, and he modified them. So it's sort of torn into panels and held on with Velcro so you can just tear it apart quickly. And he explains how to do it, how to make it. And this is part of the thing you do if you are a physical pen tester. These people who really get the job physically sneaking into banks and businesses. And this is often the case, just like you see in the spy movies. So the IRS says there's a phishing campaign targeting students and faculty, pretending to be the IRS. So, if they're sending you something with the IRS logo and talking about payment or something, be very suspicious. How can I commit more crimes? Yeah, now you can commit more crimes. Well, that's true. And you can commit them without getting caught. Yeah, that would be the goal. Although if you get authorization, you don't even have to commit crimes. But anyway, so this, I think we're going to see a lot more of this. In Cal State Los Angeles, they had too many vaccines and not enough takers, so they just opened it up to everybody, 18 and over, no appointment necessary, and for like 2 or 3 days just to use up their excess doses. And I think we're going to see much more of this. I mean, we had the first 100 million doses, and we're heading for the first 200 million doses, and I think pretty soon we're going to hit the vaccine hesitant people who don't want it. So I think they're going to be sort of like having everywhere begging you to take it pretty soon. So after Georgia passed this bill, which most people seem to think it was certainly intended to suppress the black vote, but then they took out the most offensive parts. So now the bill that is there is what the president called Jim Crow 2, but some people are saying if you really look at it, it's not all that bad anymore because they were forced to take out the most rotten stuff. But it certainly contains the most dangerous part that I thought, which is the part specifically designed to deal with Trump's phone call to Raffensperger in Georgia. And he called and said, look, I want you to commit fraud and change the vote total. And he said, I'm not going to do it. So they changed the laws in Georgia so that official no longer has the power to say no. And the Republicans in the state can replace the election officials until they get one that will do what they're told, which would presumably be to falsify the vote totals. So that is extremely serious. And that's getting us sort of into being a fake democracy like Russia, where they had an election recently and the resistance to Putin had gotten too large, so their candidate lost, so they just canceled it and changed the numbers and said they won, like Trump did. Only that worked in Russia, and it almost worked last time, and it will apparently work in Georgia next time, to just cancel out the totals and replace them with other totals that the Republicans prefer. So anyway, but in Kentucky, they made a bipartisan bill expanding voting access. So that is interesting, and boy, it would sure be nice if it showed a thawing of the lockstep of the Republican Party to be anti-democratic and anti-American, and sold to absolutely follow Trump over a cliff. It would be nice to imagine that will end. So at some point it will have to end, but it doesn't show much sign of ending yet. All right, so that's enough. I think we're up to the official time. So let's move on to the CISSP stuff. We are here, and we are here. It's Identity and Access Management tonight. And you should go in Canvas and turn in your topic, as before, for your next paper and talk, just to show that you're moving ahead on these things. And here we go. So, if you want to have any control of who does what on your system, you first have to find out who people are, and then they have to prove who they are with something like a password, so you have some confidence that you know who people are, and then you can decide whether they're authorized to do things or not. So the most common technique, the cheapest and easiest, is a password, something you know, or something like that. This is the weakest method. Many techniques of cracking passwords have been found. The simplest is that people pretty much choose common passwords, and you can just get a list of common passwords and try them. Then there's something you have, like a card, a CAC card or something, and something you are, like a fingerprint. And another one is where you are, for there are other ones less commonly used. So you can have a static password, the cheapest and most common, where you get a password and you use it for a long period of time and memorize it. Passphrases, just longer ones with sentences, quite a lot stronger than passwords. Passwords that work only once, and dynamic ones that are constantly changing. So static ones are the common ones we use, where the user makes them up, and they're very weak because people tend to choose foolish passwords. And so it's better if you have two-factor authentication and add something else to it, like a biometric or a smart card. That makes it extremely much stronger. Passphrases are just whole sentences, and it helps if you spell things wrong or add symbols and such. One-time passwords are, of course, very nice. You can only use them once, and therefore if somebody steals it, it's no good, but you have to somehow distribute them. And the only place where this is common is when they force you to do a password reset. So you can only log in with this password once, and after that you'll have to change your password. And then there's the dynamic passwords. You might get one of these RSA tokens that just has this password change every few seconds, or an app on your phone that does it. And then, it's got some non-obvious pattern to those numbers, and the server knows what number is coming up next, so they can tell if you are able to find the number on that device. So, all of those are authentication methods, and if you use only one of them, that's considered weak single-factor authentication, because there's just one mechanism being used, and a bad guy could compromise that mechanism, and then they get in. So multi-factor is much stronger, where you have to have two different factors, not two things you know or two things you have, but it's like something you know and something you have. How does the server sync up to an RSA token? Well, I think the RSA tokens go by time. So it's got a clock in here, and like every 30 seconds it changes, and this is a pseudo-random sequence calculated from a seed, and the server has the seed. So the server is basically calculating the same numbers in software at the other end. Anyway, so if you have an ATM card and a PIN, like I buy at Safeway, then it's something you have and something you know. So if somebody steals your card, they don't know the PIN, and if somebody has the PIN, they have to also steal your card, so that makes it much safer. NTP is important in those environments. Yes, Network Time Protocol. Yes, you do have to have the clocks synchronized, I would guess. Yeah. All right, so like I say, you can try password guessing. And so if somebody is trying to guess a password by logging in over and over, trying a whole list of passwords, it's pretty easy to detect that as a defender and prevent it. You can just look in the system log and see if the same user account is logging in many times, having many failures, and then you can stop it. So a clipping level would be your threshold at which you decide this is not a normal user making typographical mistakes. This is obviously an attacker, something like more than 5 failed logins per hour or something. And the best defense is to lock them out. After some are failed login attempts, then they can't get in anymore. All right. Now, in the really early days, like the 80s and 70s, we would actually store plain text passwords on computer systems in a file. But then they found out that's a bad idea. Somebody can read that file and get all the passwords. So now they store a password hash, which is a mathematical expression calculated from the password. And when you log in, it takes the password you give it, repeats that calculation, and then compares the hash to the stored hash. So it doesn't ever store your plain text password anywhere. And this would be good if the hash algorithms were very strong, but unfortunately they're not typically very strong in practice. So the way you crack this is you take a list of possible passwords again, and you calculate all the hashes, and you find a hash that matches. So in Unix systems, they're in the ets shadow file. In Windows systems, they're in the security accounts manager file. In both cases, it's storing hashes. If you have a local account on this one machine, it stores it on a local drive. If you have a Windows domain, the hashes are stored on the domain controller. And if you log in with a domain account on a Windows system, it stores a cached copy of the hash on that system. This is why ever since Windows 2000 Server, Microsoft has said your domain administrator should never go log in on a workstation. Because if you do that, you leave a record of the domain administrator hash on a workstation, which is a low security system because people are surfing the internet and installing stuff and getting it infected. You should only use the domain administrator password on the domain controller. And your domain administrator should have a low privilege account, which is what they use to log into workstations with. Microsoft has recommended that since Server 2010, but people didn't pay attention. So starting in, I think, Server 2016, they make it possible to define a policy to force that to happen so that the domain administrator account cannot be used on the workstations. Anyway, so you can capture these hashes. If you are an attacker, you can sniff the hashes as they go over the network, or you can read them from RAM with a variety of hacking tools. The SAM file is locked while the system is running, but there are ways to decrypt it. Why is it cached on a local host? You know, I don't really know why. It is, though. It's a very good question. If what you're supposed to do in a Microsoft system is you're supposed to right-click and run as, and put the domain administrator password in there, and then the password is used just to authorize one request, and that is not stored. It's something to do with the login process. Actually, I can kind of think why. The Microsoft login process opens your profile and your desktop and everything, and that process caches it locally, I think. I don't know the exact detail why, but I know it's true. This is why can't one dump the cache data? You can. That's the problem. So if somebody can get local administrator on a workstation, which is usually pretty easy to do, then they can get all the password hashes stored on that workstation, and they can use them even if they can't crack them. With a pass-to-hash attack, you can take the hash and send it over the network and authenticate it in a Windows network without ever getting the real password. That's why it's a pretty common weakness in Windows systems. And that's why Microsoft added that defense, so that high privilege accounts can be configured to never be used on low trust systems. But it doesn't do that automatically. You have to set that up. If you take Microsoft server certification classes, they'll show you how to do it. Anyway, so here's, for example, hashes. There's on a hash calculator. So if I cache password with a lowercase p and password with an uppercase p, then the most interesting ones here are LM and NT. The LM hash is E52, and this one's also E52. It's exactly the same. That's the hash system Microsoft used up through Windows XP that is really old and really insecure. And it doesn't even care whether the is capital or lowercase in the password. Microsoft updated to Windows NT in 1994, the NT hash, and that is better. This one's 8846, and this one's A4F4. It's a million times weaker than Linux hashes, but it's a whole lot stronger than the LM hashes. So a dictionary attack is the most common, where you have a list of possible passwords and you just try them to see if you can get in. So to prevent people from having passwords in a dictionary, the Microsoft defenses are password complexity and length rules that try to make sure that your password is long and that it contains a mixture of characters that wouldn't be found in an ordinary English dictionary. However, now there are dictionaries of real passwords, so it kind of undoes the value of the complexity rule. But it's still in the Microsoft operating system if you want to use it. So brute force is where you try all combinations of characters. And this is getting pretty fast these days with graphical processing units. There's rainbow tables where you fill memory with a huge lookup table to calculate the hashes faster. And there's a hybrid attack where you use a dictionary and then you modify it by adding numbers to the end or changing letters to number to try to recreate the word someone might have guessed. And these, of course, are not typically used on live systems to try logging in many times. Once you steal the password hashes, you then put them on your hash cracking system and try to run these attacks to try to do millions or billions of guesses. And then you'll find out which of those hashes are weak. You add a salt to a password before hashing it on a secure system. Windows does not do this, which is one of its many problems. Linux does. Linux and the Mac will add a salt, 8 random characters to the password before they hash it, and then they'll store that 8 characters with the password hash so that if 2 users have the same password, they will have totally different hashes, and there's no way to tell. So this prevents the rainbow table attack. You cannot pre-calculate some hashes and use them. You have to custom calculate all the hashes for every password hash because the random salt is different. And stretching is where you do many cycles of hashing. The Microsoft algorithm is 1 round of MD4. The Linux algorithm is 5,000 rounds of SHA-512. So you hash. That just makes it much slower for the attacker, which is why it is 1,000,000 times easier to crack a Windows password hash than a Linux password hash. If the salt is random, it is stored with the hash, exactly. So the salt, and just in plain text, the salt is not a secret. So your hash will have 8 random characters and then something like a $sign and then a hash. And if another person chooses the same password, they'll have a different salt and a different hash. There'll be no way to tell that those 2 passwords are the same. All right, and here's the Microsoft password settings. Have been around forever. You can remember how many previous passwords they used, so they can't reuse any of those. And then you have to reset your password within 90 days. And once you change it, you can't change it again until 2 days later. This is to stop you from changing it rapidly, like around 25 times to get back to the same one. It has to be 8 characters long. The complexity requirements are intended to beat dictionary attacks, although it's not very effective anymore, but that's forcing you to have uppercase, lowercase, numbers, and symbols. You have to have at least 3 of those things. And this reversible encryption is disabled by default. That stores your passwords in effectively plain text. And it was necessary back in the days of MS-DOS, but everybody should have it disabled on all modern systems. That's really a bad idea. All right, so users often write down their password and put it somewhere foolish, like under the keyboard or something. So that's an administrative issue that your users shouldn't be doing that. All right, so anyway, the other kind of authentication is something you have. You could have a synchronous token like an RSA Secure ID or Google Authenticator, where it's just time on that thing and matching time on the server, or an asynchronous token where you press a button to get to the next password, or you enter a challenge. The server, you try to log in, you put in your username, so the server sends you a challenge, you type in the challenge on your device, and then it gives you a number. So that's another way to do it. They're all just various ways that amount to about the same thing. All right, and then there's something you are. You get your face or your fingerprint or something scanned so it memorizes what you should look like, and then when you try to use the device, you authenticate with a fingerprint. This is like the way my iPhone works these days. So the typical rule is that in order to be not too annoying, the enrollment should only take about 2 minutes, and it should only take a few seconds to authenticate the user once you've enrolled. I know I had terrible trouble with the thumbprint reader on my Mac until a student who knows more about Macs than me showed you have to put your thumb sideways, and then it works. If your thumb is upright, it doesn't work very well at all. As far as I can tell, they didn't tell me that. Anyway, this is how you rate biometric systems that are measuring some property of your body. There's a false accept rate and a false reject rate. The false accept rate is the chance that an unauthorized person is let through. And the false reject rate is the probability that an authorized user is falsely unable to get in. So if you turn up the sensitivity, then you start rejecting more people, so you have less false acceptances, but you have more false rejects. And the quality of your device is defined by the crossover error rate. If this is, say, 10%, then your device has a 10% chance of doing the wrong thing. If it's 1%, your device has only a 1% chance of doing the wrong thing. That's a superior device. And so you can choose what sensitivity to set it at. If you're like a military base with top secret stuff, you might set it over here because you're very concerned that no unauthorized people should get in, and you're willing to irritate the authorized people by rejecting them more frequently. And if you're in a less secure environment, you might settle it here or even here because you mostly just want to let the authorized people in and you're not too worried about some unauthorized people sneaking in among them. All right. So fingerprints are the most common biometric control. It does not store a photograph of your fingerprint. It just stores a mathematical representation of some of the characteristic features, which, by the way, is how fingerprint analyses go in court. So this peak and this place where there's a matching of 3 lines, and they list where a line ends, and that's where a line ends. Those are called the minutiae, and it records those in some mathematical representation. The Retina Scan is what a doctor uses to see if you have a disease in your eye. So you have to stick your chin in a cup and have bright lights shine into your eyes and have cameras and microscopes pointing into your eyes. It's really pretty invasive and people don't like it. So most people are not willing to stick their head in a thing like that just to open a door or log into their computer. So this is not commonly used to authenticate in computer networks, although you could do it. What's more common is an iris scan. This is all you need here is a high-resolution photograph of you. You can do it with a camera from 10 feet away or so, or even further with a high-resolution camera, and then it just looks at the iris, which is the colored part of the white of your eye, the colored ring, which has a pattern in it like a fingerprint, and you don't have to get very close to you or invade your personal space to get it. It's considered very high accuracy. Hand geometry is another one. I saw this at RSA years ago. You put your hand in a little plastic brace and it just takes a photograph of the infrared picture, like the veins in your hand. And that's another pattern that can be easy to capture and effective. And there's one where you type something and it picks up the rhythm of the way you type to try to detect what they would call your fist back in the days of Morse code. The way you type can be used to determine whether you're still the same person. And you can sign with a pen and it'll record the motions you make there the same way. And your voice print is the famous one from science fiction where people will talk. Now humans can recognize a voice, even on the telephone, very well, but computer systems have famously been very bad at it. Human voices change, the way people talk changes. Being able to understand spoken speech has taken great leaps forward in the last decade or so, to where you can now talk and recite something like a phone number and the computer can pretty well understand you. But I don't think recognizing people from a voice print is still very common. This problem was popular in science fiction in the 50s, but it never really seemed to work too well in practice. Probably coming pretty soon, though. And then face recognition. This one had an interesting history. Everybody jumped on this. And after the 9/11 terrorist attack, everybody built systems and they said, we're going to put cameras in all the airports and we're going to have a list of all the terrorists and we're going to know if a terrorist walks by recognizing their face. And everybody worked on it like crazy. And about a year ago, Microsoft and other major companies abandoned their facial recognition plan system and said, we've discovered these things don't work well. They're racially biased. They finger the wrong person. I remember about 2 years ago, they tested and found that if you take the 100 sitting senators, it decides that 20 of them are terrorists. So this sounds good because humans can just look at your face and identify you, but making a device do it is turning out to be much harder than people thought. One of your banking systems has enabled, recognition by your voice system. Well, that's interesting. Well, I'm glad to hear about it. So if it works, maybe it's coming. But facial recognition seemed to peak about 2 years ago, and now everybody jumped back from it. I think they all figured out that at the moment, it's so flawed that it will just get you sued if you were to sell such a product at this point. And then, of course, there's where you are. From the GPS in your phone or the IP address, they can find out where you are, and then they can decide, for example, if you're making a payment and you are not in the same location as the store you're paying, then that would appear to be an attack, and you can use this as a second factor. Remember, when 20 of our senators are traitors, that was an absurdly high number. Well, yes, there's another point. Yes, that's another issue. I know, I was just, I was negotiating with a company that wants me to teach class in Jordan, and we had a conference call with them, and I was thinking, you guys appear to be having a coup, but I guess I'm not really one to talk. We just had a coup here. Anyway, so I remember when I was getting a gig in Saudi Arabia, and people said, "You shouldn't work there. They have a terrible government." And I said, "Well, I don't really feel that superior at the moment." Anyway, our American exceptionalism has really, I think, taken a beating lately. A lot of stuff we thought could not happen here that totally happened here. Well, in Jordan, I don't think they arrested the coup plotters. In Jordan, I think they let him go. What they did is they made peace. They decided it was okay with Jordan. They made an agreement and decided the guy was okay. Yeah, Lavon, you have Sam. What do you say, Lavon? Anyway, yeah, that was just yesterday or today. They said that they made a deal and they're friends again. So apparently the coup in Jordan appears to have been resolved. The latest thing I heard. Anyway, let's try these here cahoots. I'm on a roll. Okay, could be. Anyway, all right. All right. Let's see. 17, probably a few more coming. All right. I need to get the name of this chapter anyway, which is all right. Okay, I guess we're ready. All right, so what would you add to a password to make two-factor authentication? Yep, the IP address. A PIN is just another thing you know. That's another of the same factor. The two factors have to be different. It can't be two things you know. It has to be something you know and something you have, or something you know and where you are, like an IP address. Two things that are uncorrelated. Because if it's just two things you know, then if I steal one, I could probably steal the other. They'll both be in a database somewhere. Anyway, that's the idea. All right, what file contains password hashes on Unix? The shadow file. Yep, good. All right. All right. What stops an online brute force attack? Okay, that's your account lockout. This is what Burp Intruder does, or Hydra, and you just shouldn't let people try to log in over and over again too many times before you lock them out. What's the weakest type of password hash? Yep, that's it, the old MS-DOS one. This is the modern Windows one, which is next. This is SHA one, which is stronger than what Microsoft uses, and Linux is, again, much stronger again. LM is the really weak one that almost nobody uses anymore because it's ridiculous. You can break those in like 5 minutes on a modern system. All right, and what biometric system lets unauthorized people through? Okay, that's a high false accept rate. You have a high chance of letting somebody through incorrectly. That's what this means. All right. And obviously a low security condition. All right. All right. All right. Good, I know my winners. All right, so there's just one more section of this. And so the technologies that are used after you've used some of those two-factor authentication or whatever to find out who somebody is, then you can decide how you're going to control what they're allowed to do. Now, if you have just a bunch of individual Windows workstations in so-called work group, then you've got a mess, because if you put permissions on something, you have to go from machine to machine, adjusting the same permissions on every machine. And in practice, for a network bigger than about 10 machines, that becomes impractical and you lose control. So you have to have a point of central control, and that's why people pay for domain controllers. One point where you can make a security decision like only these users can get in this folder, and that applies to the whole network. So it's best to have one logical place, and then you have often single sign-on, where once you sign on, you have access to many systems, and you don't have to keep signing on again, because it passes your authorization through the network as necessary. And so you can have AAA services, which date all the way from the old telephone network, authentication, authorization, and accounting. And the point is, you know who you are, you know what you're allowed to do, and you keep logs recording what you did, so that, for example, in a phone network, they can send you the bill, or in a Windows domain, they can audit it to see what people have been doing, to see if they've been doing forbidden things. So, if you have decentralized access control, then you have areas that make their own security decisions that are not connected to the central point of control, and that does give you more local power, but it does mean then that you might have weak links, and this is, for example, the American presidential election. Every state makes their own election rules. Instead of having, the Democrats are trying to make federal rules that would apply to all 50 states, and that would be like a Windows domain, but our current system is like a work group where every state can just make their own decisions about how the voting goes, and that means some states do things one way and some states do it another way, and the security is not uniform. So anyway, this is DAC as an acronym usually means discretionary access control. That's a very common term. This decentralized access control is not that commonly used. So single sign-on. This is the point where instead of having to keep signing on again and again as you access different systems, you sign on just once, and then it remembers who you are as you travel through the systems. So this means it's much more convenient for everybody, but if you do manage to compromise the single sign-on system, you expose more systems. So, all right, so if you're going to do the single sign-on, then you have to have a session that sends some kind of ticket or token to keep track of who you are. And so it's recommended, of course, that you should use two-factor authentication so you know who people are. But even if you do, even if you need to steal both my card and my password to get in my account, once I have logged in, it just passes something like a hash or a ticket or over the network to record who I am. So if the attacker can steal that ticket, they can take over my session in progress, and they don't have to get my credentials at all. They can just hijack the session. So that's a problem. And so you should have a timeout so sessions don't persist for too long. And one simple way to do this, of course, would be to walk up to a workstation that's logged in when the user has walked away. So you make people lock their workstations when they leave. All right, so here's a big problem at companies is provisioning access control. So, very commonly, people who have been fired or quit still have working passwords, and they can log in later and mess things up. This happens all the time. So you should have notify people when passwords are going to expire, notify when accounts are inactive or unused and revoke their rights, remove people when they get fired or their contracts expire. When people leave, there has to be an exit interview where you explain the rules, you make them sign documents, you terminate their access to things in an orderly way. And this tends to be a very weak spot in organizations. All right, access aggregation is a common issue. Did you create a username and password at Phil's Coffee? I did. Just to test their security. Made a few of them to see how they were connected. And it was pretty good. They were using, I think, an Oracle system, and it was pretty good. Anyway, so access aggregation happens when you just get more and more access as you stay there. They give you this, they give you that. This happens at City College. They keep giving you more keys until you have a whole lot of keys, more than you actually need for physical access. Authorization creep, that's what you see here, where you keep getting more and more entitlement without shedding the old one. And so that can lead to a problem. So you should have a review of entitlements. How many privileges do people have? Does somebody have more privileges than they really should have? Federated identity management is the concept that once you have logged into one system, it is able to tell other systems, you don't need to make this guy log in. I know who this person is. So I can tell you and you can trust me. That's federated identity management. You log into one system and it can then tell other systems that it knows they can know who you are. In practice, Facebook seems to be the one. Facebook and Google are the number one things. Almost every online service says you can just log in with Facebook or Google. And when Facebook decides it knows who you are, we'll believe Facebook and trust them. And we don't even have to keep track of passwords ourselves. We'll just let you log in at Facebook and then trust Facebook to do that. This seems to be the most common solution. Obama, one of his dumb ideas, he wanted to make the U.S. government the repository of identity. He wanted to make it be the Internet ID for Americans. He proposed several foolish things like this that were abandoned immediately. He obviously was one of our leaders that really did not understand the Internet or security very well. He had quite a few foolish ideas like this. This is extremely common, of course, because government officials tend to be non-technical and they tend to be kind of old, although he wasn't, but he certainly had some foolish ideas about computer security. So when you want to send information about a security statement, like this person has logged in and I know who they are, you use some kind of message over a network, and one message used for that is Saml, Security Search and Markup Language. This is what Canvas uses. If you watch the login process, as you log into your Canvas, you'll see it's sending Saml tokens around. So this is how you can have single sign-on at internet scale. So you can have a cloud identity as a service, and then you have one central server just to identify people. And it can have two-factor authentication or something, and once it's done, then it can pass that off. Microsoft tried to do this. They provided a Microsoft password, a passport, then they called it a live ID. At another time, they called it Microsoft Accounts. I don't think it ever caught on, but Microsoft didn't try to make it so your Microsoft login would be what you used for other services. Like I said, it didn't become very popular. The popular ones I see are Google and Facebook. Oh, I guess Microsoft still has it, but I don't see people using it for non-Microsoft services much. Anyway, so you certainly want to get your employees to use a password manager. Then they have a good place to store them where they can find them. Otherwise, they'll try to I used to have like a Word document I tried to keep around, and then I had an encrypted Word document I tried to keep around. And really, that's just an attempt to recreate a password manager. That's all it is. An encrypted database integrated with your browser and backed up on the cloud, with a master password to get in. This is what everybody needs to get used to using. Isn't OAuth SSO? Yes. Yes, OAuth can also be used for SSO. Absolutely. And I think OAuth might even use SAML in some cases. I'm not quite sure. I'm not quite sure about the relationship between OAuth and SAML. I've used them both, but I'm not quite sure if they're mutually exclusive or if they can be combined. Yeah, but OAuth is a system where you send a signal to a server and say, go over here and log in, and then a server will send me like a cookie, like a ticket, that tells me I am now allowed to fetch some information from you. This is what Facebook does. You send people to Facebook, If you're like running a game or something, you say log in to Facebook. They go to Facebook and log in. Then Facebook sends you a ticket that goes back to the game server. And now the game server can ask Facebook, I need your name. And it will be authorized to get only a little information about you, but not everything. Like it couldn't get your password or your credit card number, but it could get your name and then put your name on the page. That's what OAuth does. It's very good. It's a way to manage this federated identity management at internet scale. It's also quite complicated to set up, and people often tend to set OAuth up incorrectly. Saml tends to be specific to a user. OAuth is specific to an application. The two are not interchangeable. Good, thank you. I appreciate the comments with more information. Anyway, so you'll have a password manager that can generate passwords and store them, and all you have to remember is the master password. This is a very good idea. And the main thing about it that makes it safe is that it encourages you to use different passwords for every system, which is very important because people keep getting breached. And if you just use the same password everywhere, then when that password gets breached, you've got a big problem. So you can host your own identity service locally instead of trusting somebody else like Facebook. And most companies do at least host their own Microsoft Windows domain locally, although they might put it in Azure. And then you can have your internal applications integrate with that cloud server, with that cloud identity. So you can send the information about accounts over the network with lightweight directory access protocol. This is what Active Directory uses to send information around the network. In the old version used plain text authentication. There's a newer version that does let you encrypt this traffic also. Kerberos is also used by Windows domains. The point of Kerberos was to avoid sending passwords in plain text over the network. So MIT developed this very complicated system with tickets flying around that avoids sending a password directly over the network. So what it does, it's quite complicated. You have a client trying to log in called a principal. They go into a Kerberos network called a realm, and they get a ticket, and credentials are a ticket and a service key. There's a key distribution center, a ticket granting service. You get a ticket granting ticket. It is kind of crazy, and they will always see questions on the exam asking you to record. The one with all these tickets and ticket granting tickets, that thing is Kerberos. So here's all the kind of steps. I think down here is probably, Alice wants to authenticate. They go to the key distribution center. Then you get a session key and a ticket granting ticket. Then you wish to print a ticket, your user ticket granting ticket to make a ticket that will give you a certain period of time to be authorized to do something, like use a network share. So then you get a service ticket from the ticket granting server, and now you use the thing you wanted to use, like a printer, and you have a ticket which gives you permission to use that printer for like 10 hours. It is hard to believe that it has to be this complicated, but that's what people are really using. All right. Anyway, that's the process of Kerberos. And so you typically, your tickets are good for 10 hours, the idea being that's long enough for a work day. And therefore, all the computers have to be synchronized within 5 minutes or it won't work. So you have to use network time protocol or something to make sure that nobody is more than 5 minutes off in their time. And it's got quite a few weaknesses. It's kind of an old system. The key distribution center has all the keys. So if you can compromise that, you get them all. If either of these servers goes down, the whole thing stops, nothing works. You can replay the network traffic for the lifetime of the authenticator. In earlier versions, you could actually request session keys for other users, and then you could try to crack those to get a password. And the keys are also in plain text in a client's RAM, so they can be stolen. So, it has some weaknesses, but it's still used by Microsoft domains everywhere. There is an upgrade. The upgrade to Kerberos is called Sesame, and this is intended to be stronger than Kerberos. It's got public key encryption, which prevents this plain text storage of symmetric keys. So in principle, it would be more secure. In practice, I've not heard of anybody using it, but maybe they're using it in Europe in Linux systems or something. Now, Radius is a system for remote users. This is so old, it dial-in. This is back when people would dial in on 56K modems over analog lines. And the point is they would then send their password up to the server and they could tell if they're authorized to get in there. So this is a AAA server to let people authenticate and keep track of what they're doing. An upgrade of that was Diameter, that used TCP instead of UDP. And all right, TakeAx was originally Cisco proprietary. I think TakeAx Plus is no longer. And this is just another way to do the same thing using UDP or TCP. TakeAx Plus allows you to have two-factor authentication and encrypts everything. The original one encrypted only the password but not the username. And so those are other possible systems to authenticate remote users. The original authentication, both remote and local, used PAP, Password Authentication Protocol, where you just send the password directly over the wire in plain text. This is, of course, a terrible idea. Now that we have shared wires for network traffic, somebody can steal it. So the first step to improve that was Challenge Handshake, where the server sends you a challenge, you add the challenge to your password and hash that, and then send that over the wire. And these were not terribly secure, but it's better than plain text. And then the upgrade from that was these other things we talked about, like Kerberos and such. So Microsoft Active Directory, you sort your computers and users and servers and everything into domains. It uses Kerberos, and now you have these domains can have relationships to other domains. So you can have a transitive or non-transitive trust, or a one-way and a two-way trust. So if I am Microsoft and I buy like Yahoo, I can decide that all Microsoft administrators should have administrative rights on Yahoo, but Yahoo administrators should not have administrative rights on Microsoft, that sort of thing. I can make it a one-way trust relationship or a two-way, and I can make it transitive, where if server A connects to server B and server B connects to server C, then the privileges propagate down the chain. Or I can make it so it's not transitive. So, this is why you really have to buy Microsoft servers if you're a multinational corporation, because Linux doesn't have any of this. And there are 7 Microsoft certifications, last time I looked at it, of how to run these things. The point is you can be a multinational company with 1 million computers and buy another multinational company with 500,000 computers spread across the whole world, and you can integrate their domain with your domain, because Microsoft has these tools to do that monstrous job. And if you're running Linux, none of this exists. And it's just a nightmare to correctly merge 2 companies and associate all the trust relationships correctly. So you can make a lot of money if you get the advanced Microsoft server certifications and you learn how to set this stuff up. But the tools do exist, although it's very complicated to do. All right, and then there's general access control modes. There's discretionary access control, mandatory access control, and the non-discretionary access controls. So discretionary access control is the low security one, like your home computer. You have a computer, you have access to all the files, you can do whatever you want with those files. You can email them to people, share them on BitTorrent. The owner has discretion to do anything you want with those files. This is a low security system. The alternative is what the military has, mandatory access control. The subjects have clearance, the objects have labels, so if something is top secret, you are not allowed to just share it off. If you want to share it with people that don't have top secret clearance, you have to submit it to a higher authority who has to declassify it, and that's a slow, complicated, expensive process. So this is the more secure system, and it is not simple to move something from one classification level to another. It has to go through a review process. All right, non-discretionary access control are where you don't have discretion, and the most common types are role-based and task-based, which are really pretty much the same thing. Role-based access control is essentially what you find in a Microsoft Windows domain at a company. You make categories of users, like user, auditor, network engineer, sales, help desk, whatever you got, and then you say what each group of these people can do. So you sort your people into roles, and then the role determines what they're allowed to do. This is the flexible system that's good enough for most normal businesses. A task-based access control just focuses on the task they're performing instead of putting the person in a role, which seems to me to amount to pretty much the same thing. But anyway, you fit into a task category, and then you get the roles that go with that. You get the privileges that go with that. And you can generalize it to rule-based access control. You just have a set of if-then statements. That should say if, not it. So, like firewall rules are like this. If the packet comes from this port, it's forbidden. If it comes from that port, it's allowed. If it's got this kind of data in it, it's okay. That kind of data is not okay. that's rule-based access control. And for example, login times being restricted works that way. All right, and so you can have content or context dependent that you add to it, like employees can only be allowed to see certain data from certain machines. They can only do certain things at certain times of day. These are other conditions that would limit what you're allowed to do. All right, so we're down to the last cahoots, which are here. We are done with 5A and ready for 5B. Out of focus. Oh, that's, hopefully it clears up. That's probably a buffering problem. How does geolocation work when using a VPN? A very good question. If you're using a VPN, it will not be able to identify you from your IP address, but it might still identify you from like the geolocation service on your phone. A very good point. That's the whole point of VPNs. You appear to be somewhere else, at least as far as your IP address goes. Won't you have to allow the app your location? Yes, you will. So it won't. If you don't allow the app to access your location, then the only thing it would be able to use would be your IP address, and then the VPN would conceal your location, I would think. Or the next network hop could be as close as the cable company. Well, yeah, but that's what VPNs prevent. If you're in a VPN, then you appear to be somewhere far away. They can't identify any of the IP addresses after the VPN server. All right. So let's see how this goes. All right. So what system accepts an identity from a different organization? Okay, that's Federated Identity Management. All right, what system goes on UDP 389? That's LDAP, used by Microsoft Active Directory. All right, what is a TGT lifetime? $10 is the typical. This is the Kerberos ticket granting ticket lifetime. By the way, there is a thing called the golden ticket in a Kerberos system, which is at the heart of an Active Directory domain controller, and it's good for 25 years. And the hacking tool called Mimikatz, under certain conditions, can steal the golden ticket. And if it does, the only way to fix it is to rebuild the entire domain from scratch. The guy that writes Mimikatz gives great talks at DEF CON and such. He really keeps hacking Microsoft Active Directory like crazy with clever cryptographic attacks. Anyway, 10 hours is a typical lifetime for a Kerberos ticket granting ticket. All right, what's the European improvement over Kerberos? Sesame, there you go. And what model is used on your home laptop? Assuming, of course, that you're not in a domain. That's it, discretionary access control. You own it, and at your discretion, you can do whatever you want. You don't have to ask somebody else for permission. All right. All right. All right, I've got the winners, and I'll stop the recording.